Now let's see some additional chord properties in a circle. So today's session is about the chord and the angle subtended by the chord at a point. It can be the center of the circle or at any circumference of the circle. So today's session, angle subtended by a chord at a point. So let's see what exactly we can understand through angle subtended by the chord before we understand the properties connected. What do we mean by angle subtended by the chord? So let's take a circle to understand the concept more better through the geometrical means. Suppose I take a circle and I take a chord. So for this circle, my chord is AB. In this case, we understand the angle subtended by the chord to be, say for example, by the chord at a point. Angle subtended by the chord at a point implies, if I take a circle with the chord AB out here, then let me take a point P on the circle. Now let's see what is the angle subtended by this chord with respect to the point P for the given circle. Angle subtended by the chord at a point P. So let's understand the concept through this circle diagram. So as we have the chord AB out here and the point P, I understand that this chord makes an angle with point P. We understand the endpoints of A and B for the chord make some angle with the point P. To some extent, let's see how it makes an angle with the point P. The left end of the chord AB joins with P, and the right point of the chord AB also joins point P in a manner that it subtends an angle, and this is called the subtended angle made by the chord AB. So here this angle is called angle subtended by the chord AB out here. AB, and this angle is being subtended converging up to the point P. So this refers to the angle subtended by the chord AB with respect to the point P. Chord AB at point P is how we understand angle subtended by the chord AB. If I take, say, for one more chord LM, so here is the chord LM, and here let me say there's a point Q. Then angle subtended by the chord LM with respect to the point P is similarly understood as the endpoint, the first endpoint L connected with the point, and the second endpoint M connected with the point, and then this refers to the angle subtended by the chord LM at point Q. This is the angle subtended by the chord AB at point P, and this is the angle subtended by the chord LM at point Q. Is how we understand the angle subtended by the chord with respect to the point. It's also very important to note that, say for example, I have a circle in which I have a chord AB. Say I have a point P out here. So let's see if the angle which I make on this diagram is the angle subtended by the chord AB at P. So let me just join this and let me just join this. Now let's see the difference between the angle as made by the chord AB with P and the angle made by certain distance in the line AB with point P. I clearly see that this angle is not subtended till the end of the right end of the point on the chord, but it is exactly just before the line or the chord AB. So clearly I understand that the rule for angle subtended by the chord with the point is that both the end points of the chord must subtend an angle such that we get a subtended angle of the chord. But since this gets subtended with the point, this does not get subtended with the point, therefore I say this is not the angle subtended. This is not the angle subtended by chord AB This is not the angle subtended by chord AB at point P, because this region is left over, since this region is left over, is how I understand the angle subtended by the chord at point, any point. It can be on the circle or other way. Angle subtended by the chord at a point for the given circle. Now that we have understood the definition of angle subtended by the chord at a point through the geometrical understanding of the circle, let's see some extended properties connected with angle subtension. So the first property which connects the chord and the angle subtended by the chord is as follows. So here my session is angle subtended by equal chords at a point. So let's see how the equal chords subtend an angle. So the property here says that two chords, here is the property statement, two chords which are equal in length subtend equal angles at the center of its circle. This is how the property comes. So the first property which connects angle subtended by equal chords at a point states that two chords which are equal in length subtend equal angles at the center of its circle. So let's see this through the geometrical circle diagram. Imagine I take a circle. Now the property says that if I take two chords which are equal in length, so let me take chord AB and CD which are equal in length. So I take the chord AB and I take the chord CD, provided they are equal in length. So with the first condition that the chords are equal in length, I have chosen the chord AB and the chord CD which are equal in length. That is, AB equals CD is the first condition which I take into existence. Chord AB equals chord CD. Now the property says that when I take the case of two equal chords, then the angle subtended by each of the chords will also be equal at its center. So suppose I have my center out here, then the angle subtended at the center by chord AB, and say this angle is some theta 1, and the angle subtended by chord CD, say this is the chord CD, and the angle subtended at its center O is theta 2. Then clearly the property says that for equal chords which are equal in length, the angle subtended at its center must be equal. Therefore, implies for equal chords AB equal to chord CD implies the angles subtended at its center being theta 1 and theta 2 must be equal, is how we understand the property. Two chords of equal length subtend equal angles at its center of the given circle, is how the property holds for any circle and any equal chords taken into consideration. Property number 1, connecting angles subtended by equal chords at a point are equal, is how we come with the property.
If you like this video, please give a thumbs up. Please subscribe to our channel to get more videos on CBSE syllabus.